Hey guys, so this is a video for 4.3. It's all about logarithmic functions. You learned about logs before in Algebra 2, and we're just going to dig in a little bit deeper, plus review all those other skills that you had in Algebra 2. So, last time we talked about e. E is a very specific type of exponential function. So it has all those same properties that we talked about before with e. We had talked about interest. And one thing with interest we didn't talk about was how interest can compound continuously. Okay, and there's a formula for this, and it's p times e to the rt. And it kind of rhymes a little bit. P times e to the rt if you want to compound continuously. Okay? So you can dance to that if you want, or you can just use that to remember it, whatever floats your boat. So same thing, you've got principal, e is just e, rate, and time. Okay, so any of the word problems that you've been working with that say, we have problems that say compound quarterly, that means 4 times. Compound continuously just means over and over again. Okay, so moving on to new material, we're going to talk about logs and natural logs. So every function has an inverse. What's the inverse of addition? Subtraction. What's the inverse of division? Multiplication. If I have a square root, what's the inverse? How do I undo that? I square it. Okay? Every function has an inverse, something that undoes it. Okay? And if you graph any of these, you would see a very interesting pattern between all of them. And so the log function is the inverse of the exponential function. Okay? And a log function, its natural base is 10. Okay, so people have 10 fingers and 10 toes, so of course it makes sense that the base is 10. And natural log has a base of e. So the base for log is going to be 10, and the base for natural log is going to be e. And you'll see a little bit more what that means in just a sec. So let's go ahead and make some notes about this. So we've got log, I'm going to call it its default base is 10. So if I see something like log with maybe a number, I'm going to assume that there's a 10 here, even though I don't see it. Okay, we don't have to write it. It's kind of like when I see x, I automatically know that there's a 1 in front. With natural log, it has a base e, so you could rewrite it like this, log base e. You could have log with base with any number. I could have log base 2. You could have log base 5. Okay, the base could be a fraction. It could be anything. Okay, so those are our inverse functions for the exponential function. Okay, if I want to undo 3 to the x, I can use log to do that. If I want to undo e to the x, I can use ln to do that. And so if you want to take a second, look at your calculator, you should see an ln button and you should see a log button. We're going to be using those a lot in this section. Alright, so as always, let's look at the domain and range. So last time, you should already have this in your notes, we talked about exponential functions, something like 2 to the x or 3 to the x, doesn't really matter, or even e to the x. Its domain is always going to be all real numbers, its range is going to be from 0 to infinity. We're going to have a horizontal asymptote at 0, no vertical asymptotes, and a y-intercept at 1, because if I plug in 0 for x, I get 1, and no x-intercepts. Now, a lot of those things could change just by me doing my transformations, moving that function. This is the log function, okay? You should notice that there's a relationship between these two functions, and there certainly should be if they're inverses. So this time my domain is 0 to infinity, and my range is all real numbers, okay? That's flip-flopped from the exponential function. This time I don't have a horizontal asymptote, but I do have a vertical asymptote at 0. Again, Got my lines crossed. So this time, it's flip-flopped. My y-intercept, again, I don't have one, and my x-intercept I do. One last time, flippity-flop, okay? So those are the graphs of your logarithmic and exponential functions. I'm going to show you what they look like on the same graph. Okay, so here is my exponential, here is my logarithmic. There's a relationship. It's a reflection across the line y equals x. Just like you should already know about inverse functions. Remember when we had to find the inverse of a function and we would switch x and y and solve for y? This is y, okay? I just said y a whole lot. I'm really sorry about that, but this is y, okay? So, once again, because we love our transformation rules so much and they help us out a whole lot with domain and range, we're going to do our transformation rules with this new function that we're talking about. So, think about what your parent function log looks like, okay? What I want you to do is just pause the video and try to match them up real quick and then play it when you're ready. Okay, so I'm going to go over these now. Hopefully you paused it, you tried it, and the base doesn't matter, okay? This one is positive, nothing's happened to it. This is my parent function. So I'm looking for something that looks like this, and that would be 3. So 3 is A, okay? Now B, I've got a negative on the inside. That means it's a reflection across Y. So I'm looking for something that just kind of went over on the other side of the y-axis, and that's going to be 2. C, now I've got a negative on the outside, that's going to reflect across y, so I'm looking for this flipped upside down, and that's number 1. And the last one, I have both things happening, it's flipped upside down and over. Okay, so using our transformation rules. If I want to move something up, doesn't matter what the base is, I'm going to add a number to it. If I want to move something left, I'm going to add on the inside. All those rules are the same that they've always been. Okay, if I want to vertically stretch it, I put a number on the outside that's bigger than 1. If I want to shrink it, less than 1. All the same rules, no different. So what I want to focus on now is a very basic skill that you're going to need in these next couple of sections to actually solve, so we can actually apply this math to something that really matters. And what we need to do is rewrite it we need to get comfortable rewriting from exponential to logarithmic form and logarithmic to exponential. So we're going to go back and forth. Now, if you had Miss Martin, she says blah to the blah equals blah. Okay? So if you know that, that's what we're doing. Okay, if that triggers something in your brain. What I say is left to the right equals center. Okay, and there's a nice little pattern here. So if I have log base A of B equals C, it goes the number that's on the farthest left, so whatever this is, A, the number that's on the right, C equals B. Now this will make a lot more sense when I take out the letters and actually put some numbers in here. So look at number 7. The number on the far left is 5. The number on the far right is 2. The number in the center is 25. So I've got a left, right, center. Okay? So blah to the blah equals blah. Okay? Should make this little horn doohickey. Okay? If you like that. So let's do one more. 5 to the 0 equals 1. Okay? 5 to the 0 equals 1. And that's a true statement. That's all we're doing is rewriting. And then eventually I'd like to be able to take something like this and put it in logarithmic form. But right now, this is really what I want you to focus on. Okay, go ahead and take a second, try these on your own, pause the video, play it when you're ready. Welcome back. 8 to the 1/3 equals 2. That's true, because 8 to the 1/3 is the cube root, and the cube root of 8 is 2. 2 to the -3rd equals 1/8. That's also true, because 2 to the -3rd is the same thing as putting it under 1 and making it positive, and 2 to the 3rd is 8. Okay, again, try these on your own first. Okay? 3 to the 4 equals 81. 8 to the 2/3 equals 4. So let's just make sure that's right. 8 to the 2/3. Well, 8 squared is 64, and the cube root of 64 is 1. So a lot of that stuff that you would have done in algebra, like these exponent rules, that's going to come in handy. All right, so let's look at some ln ones. What I like to do, because I'm a very visual person, but you don't have to do it this way, is I like to rewrite ln as log with a base e, because that's exactly what it is. This way, the little blah to the blah equals blah trick still holds true. And I can rewrite this as e to the x equals 5. So e to the x equals 5. ln base e of y equals 5. E to the 5 equals y. Alright, try C on your own. And play it when you're ready. Log base e of e equals x. So it's e to the x equals x. Or e to the x equals e. Can I actually solve that? What would the value of x be? E to the what gives me e? 1. And that's what we're working towards. We're going to use these skills to actually solve. Okay, as much fun as it is just to rewrite this stuff, that's not why we're doing it. Okay, we're using it because we're going to actually use it to solve. You can even use this if you have ln of a quantity. Okay, so this has been shifted. I'm going to do log base e of x plus 1 equals 2. E to the second equals x plus 1. Could I go ahead and solve? You betcha. How do you get x by itself? Subtract 1. E squared minus 1 equals x. Okay, try this one on your own. Log base e of x minus 1 equals 4. E to the 4 equals x minus 1. Just add the 1 this time. E to the 4 plus 1 equals x. Okay, you don't have to actually simplify, you can leave it. It's kind of like working with pi, because e is, it's not like a set number. It goes on forever and ever. It's irrational. So here's another joke. Okay, so these two are checking out this log function. It's log base 10, and pi is really digging her. E is not so impressed because she's not natural. Get it? Okay? So he would be much more interested in ln, because that's a natural log. Alright, so what we're going to do now is we're actually going to use our skills to solve. So I'm going to work through these quickly. At any time, if you feel confident enough to start solving, go ahead and pause the video, try some on your own, play to check your answers, and let me know if you have questions. Alright, so I'm going to rewrite this. 5, there's no x over here, so I'm just going to write x for me. 5 to the x equals 5 to the 4th. 5 to the x equals 5 to the 4th. What would x have to be? 4, silly. Again, put x. 4 to the x equals 64. 4 cubed is 64, so x has to be 3. 3 to the x equals 9. X has to be 2, because 3 squared is 9. Alright, 2 more. I hope that by this point that you're pausing the video and you're going to try these on your own. X to the 3rd is 27. X has to be 3, because 3 cubed is 27. 2 to the 5th equals x. Switch this one up on you a little bit, okay? Making you solve for something different. 2 to the 5th is 32. Alright, so I'm going to pause here. Now I have 15 minutes of free recording time. And I'm going to make another video. So if you need to, go back and rewatch this stuff first before you move on to the next video. And when you're ready, then you can move on.